So, this next section, you need to really pay attention. Not because it's hard, but if you miss something, it ruins everything. So, the first thing we need to understand, we have a P of X equals a D of X times a Q of X plus an R of X. Now, this P of X represents your dividend. This is your divisor. So we're going to be divisor, and I still spelled that wrong. I missed another I after the.
Is there a difference between lowercase and capital?
This one they put it with the little lowercase. I don't know why, but that's the way they write it. So I just listen to what the book says. I just follow the recipe. This is your quotient, which is your answer, and this is your remainder.
It's divided.
Oh.
I thought the same thing.
Dividend. It's like divide and ND. Dividend. Remainder. Now, back when you were little, like 2 years ago, you had problems like 652 divided by 4. Remember problems like this?
Yes.
Now, how did we do the problems? We would say, hey, 4, how many times does 4 go into 6? Correct?
1.5 times.
Sorry.
1.
So it goes in 1 time, then you would take that 1 and multiply it times the 4. And what would you put in here? Subtraction, right? And then this would be a 2, and then you would bring down the next number, and that were 5. How many times does 4 go into 25? It goes to 6. 6 times 4 was 24. We subtract. So on, we bring it down to 2. And 4 goes into 12 3 times. That's 12, and you have a remainder of 0. Now, this is your dividend, the number that's inside. This is your divisor. This is your quotient, and this is your remainder.
It was the quotient.
Quotient. This is your divisor. This is your quotient, your answer, and this is your remainder. So, if I had to write this out in this kind of form, it would be 652 equals 4 times 163 plus 0. So the dividend equals the divisor plus the quotient plus the remainder. We're going to be doing this, but with polynomials. So this is where it could get messy if you don't write everything down. So for the first example,
Wait, so the divide, explain that one more time. Which one's the divisor, the quotient?
The divisor is the 4.
Okay.
The quotient, so this is your divisor, this is your quotient, and this is your remainder. And the dividend, it means it's the original to start off. All right, so for example number 1, let's say I had x minus 3 as your divisor. And I need to divide x to the 3rd plus 2x squared minus 5x minus 6. So I need you to be open-minded about what's going to happen. And listen to what I'm saying. So to start off with, I understand I have 2 things right here. We only care about the first one for now. And I know I have 4 things here, but I only care about the first one right now. So the question you ask yourself is, what times this is going to give me this? What times x is going to give me an x cubed? X to the second, and that is correct. You're going to put your x to the second up here, because this is where your x to the seconds go. If my answer would have been an x cubed, then it goes on top of this. If my question was just, my answer would have been an X, it goes here, if it's just a number, it goes there. So, we're saying X times X squared, when I multiply this, because remember here I did 1 times 4 was 4? Yes, so here I have to do X squared times X, which is?
X cubed.
X cubed, but also, now, don't forget about that -3. What is X squared times a -3?
-3 X squared.
-3x squared. So whatever answer you have here, I do have to multiply both times it. Now,
So whenever you
one
You
more
just-
time?
you add the exponents when you're multiplying, right? That's what I thought.
Yes. What happened, Joe?
I just don't understand you got 3x to the second, -3x to the second.
Because 2x times x, 3x, x cubed, right?
Yeah.
But x squared times a -3,
Oh.
-3x squared. So I have to multiply this times both. Okie dokie? That times both of those. Huh? I have to multiply your answer up here times both of these. So that's where I get both of these answers. Now, what did I put up in front when I did this?
Minus.
A minus. Now, this is a positive, it becomes a minus, but if I put a minus in front of a minus, it becomes a who?
Positive.
So you're gonna have to be careful with that.
So you change both sides.
Both signs become opposite.
Well, I don't understand, we got the negative, say that one more time. Okay.
We have to subtract there, whatever the answer is, we have to subtract the answer. So you're originally, I'll paper here. So when you did your x squared times x minus 3, we got the x cubed minus 3x squared, which is what I have here, right?
Yeah.
Yes? So when you put it here, I'm supposed to put a subtraction in front of the whole thing. Subtraction, this becomes a negative, but this becomes a positive. So just stick it in your head that they're gonna always become the opposite sign of what they were originally. Now, x cubed minus x cubed becomes, and that is your goal. If that happens, you did the right thing.
So you're trying to cancel out.
Yes, and that's the whole thing. Now, what is 2x squared plus 3x squared? 5x squared, but don't forget, you bring down the next term right there. Just the way we brought down the 5 and the one on top, you bring down the 5x here. Now, once again, you only care about the first one, you only care about the first one. So what times x is going to give me the 5x squared?
5x.
5x.
Okay.
So it's 5x.
Then x sub x is x squared.
So a positive 5x. So this 5x, right, times the x is who? 5x squared. This 5x times the -3,
-15x.
-15x, but then this becomes a minus,
That's
and this becomes a positive. Did these two cross out?
Yes.
Yay, I'm doing good. -5 plus 15, 10x, and don't forget to bring down that -6. So now you only care about these two. What times x is going to give me the 10x? 10. So I have to put a plus 10 here. 10 times x, 10x. 10 times a -3,
-30.
-30. This becomes a minus, this becomes a plus. Crosses out.
-20.
Positive 24. So if I had to write out my answer,
That's your remainder.
that is my remainder, that is correct. My P of x, which is x cubed plus 2x squared minus 5x minus 6, is my answer, right? It comes from my divisor, which is x minus 3, times my quotient. Who's your quotient? X squared plus 5x plus 10, plus my remainder, which is 24. I don't think they ever make you write it out like that. What I've seen is they'll tell you, hey, who's your Q of X, who's your R of X? So you need to know my Q of X is your quotient, which is your answer up here. So you would just say, type in x squared plus 5x plus 10. Who was your remainder?
24.
24. Now, if this makes sense, awesome. If half of it made sense, great.
So you don't have to solve for X?
No, you don't have to solve for X.
Because, what if there was a 3 instead of an X in front of that? Then you would have a number, right?
Front of who?
Huh?
If there was an X in front of who?
No, if there was, instead of that X minus 3, it was just a minus 3, or if it was just.
No, you need a factor.
No, I'm saying, what if there was no X? There can't be a 3 divided by X cubed.
And take away the X completely.
How do you not understand what
I'm telling you, you need to have an
It
X.
has to.
So
It has to
there's
be.
never
That's
gonna
why
be
I
a
said
problem.
It has to be a factor. This is a factor.
So it's never gonna have just one number there, ever. So the first question ain't gonna pop up like that.
It could be an X squared plus 3X. It could be like a bigger exponent. There's gonna have to be an X in it.
Okay, so
There's gonna have to be an X.
there's really not gonna be an actual number.
No, that's.
It could probably, well, no, it's not. It's gonna be a factor.
I just wanted to make sure. It's a good question.
All right. So, are we okay with that right now?
Yeah.
Yes?
So we're not gonna multiply it and all that.
No, you don't have to. Now, basically what this means is if I were to distribute here and get everything and then add 24,
You don't get that.
you're gonna get that. Exactly. That's what it means.
So that's how you can.
Okay, yeah. That's how you can check, yeah.
That's what I'm saying. This is just a check. So
All right.
it's crazy.
This can do the test.
Yes, this is gonna be in the test. Example number 2, long division. Again,
Honestly, did you just do that?
yeah, there's one more. X minus 2 divided by, or not, it's not divided by, but it's x cubed, 4x cubed, minus 3x squared, plus x, plus 7, is divided by x minus 2.
So we're gonna try this? Let's try this?
So,
Okay.
try to find the first number that goes up here. I'm giving you 20 seconds. What times this, just to put the right number up there, I'm not saying to finish everything. What times this gives you this? Don't say it, write it down.
So it'll go over the,
It
where
go-
your finger is.
Yes. What times this gives me this?
X, I'm sorry.
5. Is that what you put up there? Yes.
That's not what I was gonna say.
Is it?
Now, why is it a 4x squared? Because this guy has a who? A 4.
And that's a 1.
So we don't work.
Oh, I
You don't remember I said
Until it connects.
you only look at this to figure out the number up there, but when it comes to the multiplication, don't forget about that -2. So then do the next step. You take this one, and you have to multiply both, and write it right there.
Is it gonna be the same?
Wait, do we repeat that again?
Just minus one, it's like set 4x3,
No, that's,
x2, and then like, say if it was 5x3, just 5x2.
So, for the next step, you're probably gonna work on the 3x to the second with that -2 over there.
You have to, the next step is to take this answer
Multiply.
and multiply both of these and put them right there.
Exponent.
Because remember, you find, multiply, rewrite. Find, multiply, rewrite. Find, multiply,
okay,
rewrite.
I got 5. Oh,
Hold your horses. So write down, change the signs.
yes. Yeah. Flip side. Whatever.
So So that was the next step. You multiply, you rewrite, meaning you combine. So now find the next number up on top.
And again, we're just worried about the 5x squared
When you're finding the number on top, yes.
and the x. Okay.
Only the 5x squared and the x when you're finding the number on top.
So wait, was the first one not long division?
Yeah.
It was?
Yeah, I just didn't title it long
Okay,
division.
just making sure.
We're just doing the exact same thing.
Exact same thing. So now I put a label on it and you're freaking out. Just kidding.
So that happens.
So, 5x, did y'all get to multiply already?
Yes.
Wait, hold on.
Then the only thing I forgot is like, how did you get the 5x?
Cause you have
Yeah, where did
one
the
multiplies,
This 5x?
No,
No, the one on
the top.
Because 1 times this gives you this.
Oh.
1 times this gives you this.
Oh.
Because that was the first thing that was there, that was the only thing that was there. So you only care about the beginning of each one.
It's kind of like you start over again. Kind of.
Yes. That's exactly what it is.
Hold on, one second.
I hold. If you think you got it, go ahead and continue.
whoa, take that.
So do the last step.
Is the remainder gonna be, factor times? We got 2.
So just tell me who your Q of X and your R of X are.
Q of X is the first 11,
Mm-hmm.
and then the RX is 20.
So, not bad, right?
So do you think that's how they're gonna, have the answer on my math lab, the Q?
I saw, like, I skimmed through it, and like 2 out of the 5 questions, they have like Q of X and a little blank for you to type it in, and the R of X.
I stumbled over, I got to the 4x, and then when we came to the 5,
It's just you're starting over again. Because once you do the 4x, you're right there. So it's the beginning and the beginning. It's the
so you
beginning of the
multiply the x minus 2
Do you multiply to x minus 2 times?
to get,
Well, you only look to what times the x is gonna give you the 5x squared.
okay.
You only care about the first one of each one.
Yeah,
The
okay,
first
the
one.
x, what do you have to multiply?
But then, once you put the 5x here, you have to multiply both and put it there.
Okay, so you won't ever do the x minus 2.
When you're looking for the number on top, no. But once you put the number on top, you have to use both. Okay? Now, this next problem, they're gonna word it differently. In example number 3, they're gonna say find Q of x and R of x given that P of x is x to the 4th minus 2x squared plus 3, and your little d of x plus 2. Now, before you start writing it down, I need for you to look at your P of x right here. How do you see that this P of x is different from the previous 2?
It's missing an x to the 3rd and an x.
Very good. It's missing an x cubed and an x. It doesn't have you see how this one had x cubed, x squared, 1, and then the constant? So when you write this out, you have to, if not, it's gonna come in.
You have to give it an x3.
You have to put the x to the fourth, there's no x cubed, so we put 0x cubed. Is there an x squared? Yes, you put the x squared. Was there an x? No, so we put a 0x and a +3. There has to be a place for each one.
I see what you're doing.
One
there.
second.
It's not a 1x3 or a 1x?
No, it's just zero.
No, there'll be zeros. There'll be zeros.
So we're making them up.
Or we can spell x3.
No, because if you put x3, it means there's a 1. And there's no, like this one, there's a 1x to the 4th. So if you don't have an x cubed or an x or whatever's missing, you have to put zeros in there.
You have to.
You have to.
Did you just make that up? Oh, no, that's a good.
It's a D.
That's it.
So my divisor goes on top.
So pay attention.
I'm sorry.
Oh my god.
That's a one.
Right.
So, look for the first one. What times? Who? What times what?
X times
cubed?
3.
X cubed.
X cubed.
Okay, but you see, I just want for you to ask yourself the question, what times x gives me the x to the 4th? Put the answer where it belongs. What times x gives me x to the 4th? Bam, you wrote it down already?
I'm not sure anymore.
Since it's an x cube, it goes on top of the 0x cube. Now,
What do you call that number? The little degree?
cube,
I mean, like, is there like a name for that if it was like a 2 or?
square, they're your powers, they're your exponents, they're your degrees.
So is it always just gonna be the same as the first number, just with the smaller exponent?
Most of the time, yes.
Or is that what that was looking?
Because if this had a 2, then what times x squared is going to give you x to the 4th? And that's 2, so we would go over here. So not necessarily is it every time going to be 1 less. Yes, Anthony?
It's never like an X to the fifth. It gives you an X to the fourth, right?
Mm-hmm.
It's never gonna be that fifth.
I don't know, Mike.
Yeah.
Alrighty, so let's worry about this part. Let's not worry what ifs.
What are we talking about?
Kind of.
I kind of zoned out, like,
Is it all, are your exponents always gonna be in order like that, or if they're,
You have to put them in order.
okay,
If they give them to you in the equation, they're not in order, you have to put them in order.
okay, so then the x3 will go above the x3, the x2 will go above the x2.
Alrighty,
So
so
that's-
have you already taken care of multiplying the x cubed times both of those?
Yes.
Do it. If you have it, come on.
Would you bring down the 2x? Because that 0% minus it. So it doesn't take nothing away. Okay. That's
Okay. To me,
You forgot the sign on the.
it's always gonna be the opposite of what you do when you multiply. So this was a positive
Oh,
x to
okay.
the 4th, this was a positive 2x cubed, but you have to change the sign.
But when you bring it down, you keep that sign.
Well, it depends. When you add it, if this would have been a positive 4, it wouldn't have, you
I
wouldn't
meant
have.
the 2x squared, but when you bring down the 2x.
Oh, this one?
Yeah.
It sticks. So it's the same one. So right now, who do I only care about? The first thing here
just 2x.
and the first thing there. Only those two. So what times x gives you a negative 2x cubed? Write it down, don't tell me. What times x gives you a negative 2x cubed?
Got it.
Put it right there. take that negative 2x squared and multiply both of those thingies by it.
You know, if you're doing wrong, you can't cross out those first.
Yes.
Negative 2 times 2, that's 4.
Negative 2x squared, but when you bring it down, you're gonna have to change it. So you also have to-
Positive 2x squared. Bring down that. Let's do that. So you go to positive, it's positive. Right? Let's just that square, cancel out, that's 0, which is 1.
Are we okay so far? Zero x, because right now you're gonna get something with an x and it goes right below it.
Oh, I tried to for that.
Two x times 2 is 4x. Now with a positive, but because I have to change the signs, it becomes a negative, so now we bring down z. You will only get one problem of long division on your test. Only one. Oh, you're good at it? Right now, did I show you synthetic division?
Easy things that she gives you.
Oh, I'll give you 2 if you want to.
Make it
You know
3.
what? There's gonna be 3 problems. You can have one long, one synthetic, and the other one you can do whatever makes you happy.
She talking
What's
about
the
oil
difference
change?
between
But once I show you synthetic division, it's a lot easier. You're gonna.
That's a box number, right?
So what number goes up here?
Plus 3.
Minus 4.
I knew that. Because that's what, how you get 4x, right? So, yeah.
I just had to finish my hair.
And negative 8. Change the sign.
Okay, I'm hungry again.
Your cube x cubed minus 2x squared plus 2x minus 4. My r of x is a 11. So I'm gonna do this problem in about a minute, and I'm gonna do it using synthetic division. And you're gonna see how much easier it is,
Drive smooth.
but synthetic division cannot be used every time. Any questions on this problem, first of all?
No, hold on before you.
All right. So are you guys comfortable, at least an 85% with the long division?
Yeah.
So it's not, like I told you at the beginning, it's not that it's hard, but you have to be careful and keep your x squares with your x squares, your x's with your x's, because if you don't, then we run into problems. Very good?
So then,
All right, so then, all right, example number 4. Synthetic division. Now, let's go ahead and give x. I'm just gonna rewrite it because I have to flip the page. It's exactly the same problem that we did earlier. Now, when you use synthetic division, you don't use a factor, you use the 0. So if this is a factor, how do I figure out the 0?
Set it to 0.
Set it equal to 0, right? So I have x plus 2 is equal to 0, minus 2 minus 2, so x is a negative 2.
I have a question.
This is a number that I have to use for this problem. So I'm going to start off by doing a little table, I don't know what you would call it, and I'm gonna stick the -2 on there.
That's not right.
Next to this,
What is that?
you're gonna write only your coefficients to this.
One, two.
So I have a 1, but not a 2 or a -2. I have to put a 0, -2, 0, and 3. So just the way like in the other one, I needed an x to the 4th, x to the 3rd, x squared, x, and your constant, it's the same thing here. If it's missing, you have to put the 0. Of course. Rewind.
What's going on?
So I only care about the coefficients. But I have 1x to the 4th. There was no x cubed, so I have to put a 0. There was a -2x squared. There is a 0. There is no x, so you have to put 0x, and your constant is the 3.
Because you have to have.
Because you need to have a place for each thing.
Gotcha.
Now, synthetic division, piece of pie. The rule is you bring down your first number, which is a 1. This number you multiply times your 0,
Autos.
which is a
You multiply times your zero, then you multiply
times whatever your 0 is, which in this case is,
-2.
That's
so
fine.
I put a -2 here. What is 0 plus a -2? 2.
Of course.
This -2, you multiply times the -2 out here, which is a
Positive 4.
positive 4.
I think
A -2 plus 4 is positive 2.
2x to the second.
The 2 times the -2 is a
-4.
-4. 0 minus 4 plus -4, whichever way you want to say it. -4. And the -2 times the -4 is an 8. And 3 plus 8 is 11. Now,
First number, you don't go to.
but you just bring it down. And then you multiply, add or subtract, multiply, add or subtract, multiply, add or subtract.
Then add.
Now, this here is your, sorry, what?
So you bring down the first.
Bring down the first. So I go through it again. Bring down the first, you multiply, you put the number there. You add or subtract that, and this is what I get. You multiply times this, you put it here. You add or subtract, you put it there. You multiply times the -2, you put it there. You add or subtract, that's what you get. Multiply, put it there, add or subtract, there it is.
you can see the pattern. My kind of.
Now, this here is your remainder. This is your constant, this is your x, this is your x squared, and this is your x cubed. Which means my answer is 1x cubed minus 2x squared plus 2x minus 4, and your remainder is 11. If you look at this answer, and you look at your previous answer, it is exactly the same thing.
What happened to the x is 4?
It decreases because you're dividing.
But this doesn't always work.
It works if this is a factor. If you give it to you like an x plus 2 and x minus something. But if they give you divide by x squared plus 3, it won't work.
Okay, this only works when they're.
You have to use long division for that.
So we can use either way, we obviously have to move switch to the plus.
Well, this is a lot easier.
This is harder for me.
Well, it's because you haven't given it a chance, believe me.
Dang.
Yeah, this is a lot.
This is a lot cleaner because there is no x squares and all that
Yeah,
stuff in
there are
there.
no steps.
And then you have to put an opposite sign and stuff.
But it's
You
limited
can only use it.
It is not, it's limited
Like what?
to what?
everything for right now.
But you said you can only use this method if it's a factor, right?
Yes, but everything that I saw on my math lab is just a factor. So,
No, it's
that's, yes, talking.
Then like, d of x equals x squared plus 2, you have to use long division.
You have to use long division. So,
Factor means it has no power.
yes, exactly. Try this one. X cubed minus 9x squared plus 15x plus 25. And your divisor is
She made it easy for
x. Oh, of course it's like
Ah, man.
just when I was getting into it.
fastest move.
So use synthetic division with this one. Let's see if you can put the numbers, the right numbers where they belong. What number goes outside? Am I missing a variable?
Yeah.
No. So you don't have to worry about putting zeros because you have x cubed, x squared, x, and your constant.
We're doing the synthetic way, right?
Use this as synthetic.
Oh, this is the better?
Yes, use synthetic. Use synthetic.
I got you.
You got me? I got it.
What just happened?
I got it.
So no kids? No, I'm just kidding. I hit home with that. I'm so sorry.
Did you just throw something in there?
Never. I wish I could have done something else.
I hope so. I mean, at least it wasn't a chocolate. That's what I'm, you know, that would have given me flashbacks. PTSD would have kicked in.
All right, what number did we put up? No, I'm just gonna put down the numbers, just making sure. What numbers did you put up here? A positive 5.
Oh, I
And
see.
You got 1, -9,
Oh, yeah.
15, 10.
All right, now, we're just making sure you got that, but work it out.
So you always leave the X out and you flip what?
You set it equal to 0 and you get a positive 5.
Oh, I didn't
Remember-
set it equal to 0. Oh, yeah.
Remember that, why is that you just forget the X?
Because it's synthetic.
Oh, it's been awesome.
When it took into the x, it doesn't have to end in the constant.
It is in the remainder, all the time,
The constant.
the remainder.
Even if you have a 0.
Even if it's 0, your remainder is 0.
Okay, then.
All right.
No.
So you drop down the wood, and then you.
Can I work it out now?
Yeah.
Please.
Okay,
Work it out.
so bring down the 1. This becomes a,
5,
this becomes a,
-4,
this becomes a,
It's so bad.
this is a,
-5,
this is a.
-2.
So, this you get a 0. Perfect. You always label with the R, C, X, X squared. You always label in reverse. So my answer here is
X squared.
X squared minus 4X
-5.
minus 5. And remainder 0. Now, I need for you to now understand why the remainder is 0. The remainder is 0 because this is a factor to the answer. This is not a real factor to it because it's not a 0. So a factor is a solution. So if I were to graph this, it's going to cross the graph at positive 5. This one is not going to cross at -2 because this is not a 0. Once again, if your remainder is 0, then it is a factor. That's how simple it is. Don't stress out. It's just words coming to my mouth. If the remainder is 0, then the factor they give you is a factor. It is an actual answer.
I feel good.
Can you move up?
That's the answer. You good? Good, good.
That is good.
All right.
I had the right number, I had the wrong, okay.
Whatever you start with, it's gonna be less than.
So you
X
just
squared,
take
you're gonna, I mean,
one
X
X
cubed
away
is
from
gonna be
everything.
squared. Cause you subtract one.
Because this is an X. Yeah.
So your answer, you're gonna just take one X away from.
Because this is an X, yes. But if you're dividing by an X squared, then it goes down by 2. It just depends what they give you. So I don't wanna say yes, but all the ones I saw in my math lab and all the ones that they have for practice in the chapter, it's only an X plus or an X minus. So right now the answer is yay, but you could get problems where it's not. And I'm just gonna do one just to, and it's not gonna be an answer, just so you can see. Give me a problem, whatever makes you happy. This is extra right here. You don't have to write it down, just look.
I got it.
7x cubed.
7x to the 5th minus 3x to the 4th plus, don't write this down because this is just because
It's just showing off.
x, yes sir, we're just showing off, why not? Plus 0x minus 5, and we're gonna divide by x squared plus 3x minus 1. So, you will get a problem like this. This problem, you will not be able to do in synthetic. Do you understand why?
Because it's an x squared.
Because it's an x squared. So, all you have to worry about is exactly, and it's just because of all the questions that it goes down all the time just by 1, no. What times this is gonna give me this?
7x.
7x cubed. 7x cubed is gonna give me that. So 7x cubed times x squared is 7x to the 5th. 7x cubed times 3x, 21x to the 4th. 7x cubed times a negative 1,
Negative
7x cubed. A minus, and a plus. Cancels? Oh yeah. Negative 24x to the 4th. 9x cubed. Bring down my pen here. So now you only care about the first one. What times this is going to give you this?
Negative
4x squared.
So it's not that it's any harder, it's just more of what.
Yes.
Just not.
It's just you need to be careful with your x's. Now, so just here, I'm not going to finish it, but did it just decrease by 1?
It decreased by 2.
It decreased by 2 because this was a power of 2. So just to answer those questions, because then next time that you take another class, it's like, but Miss Tanya said it. No, I never said it's always going to decrease by 1. The ones in your assignment are set up like that, but this could happen where it decreases from an x to the 5th to an x cubed.
But in synthetic version, like if you are able to do synthetic, the exponents are also by 1.
And synthetic, yes, because that's the only way you could do synthetic, for it to drop by 1. Okay, so are we good with long and synthetic division? Yes? All right.
It's the
Says it one review.
The remainder theorem. Given
Yeah, I recognize that pin.
f of x and a value c.
Is this still 4.3?
Yeah, this is a very long one close to the end. Then you will find f of c. And what does f of c mean?
Constant.
It's not, this is a constant, it could have been a. You're gonna plug in the c for every x and the function they give you, right?
Okay.
Okay. Which will give you the remainder. So you're gonna have a question or two that all they care about is the remainder. That's it.
So will you have to work that whole problem out, or you just do this method?
There's two ways you could do it. You could do it through the remainder theorem, or you could just use the synthetic. And I'm gonna show you both ways, they both give you the same answer. So what example am I on? That was 4. Was there a 5 here? No. So this is example 5. So example number 5, find the remainder. And I can't spell remainder again, but whatever. F of x equals 2x to the 5th minus 3x to the 4th plus x to the 3rd minus 2x squared plus x minus 8. Now, they're going to give you f of 10,
Okay, that's for Tennessee.
Tennessee. Oh, Tennessee, like Nashville, Tennessee. I'm sorry, it just, so what do we have to do? Replace every x with a 10, right?
Oh, that's a good.
Semicolon.
Oh my God, is this English?
I just think that's what I was about to say earlier.
Why did I say that?
You just put 10 in all your.
Yes, ma'am, thank you for staying on topic, not being like some other.
Hey, Anthony's been killing this service.
There's a fun remote, AFX. Which I'm not gonna.
I've been like dying to say this,
You
bro.
thought it said find the remote. That's horrible.
Oh, that's what that, okay.
Thank you.
That's messed up, bro. I put the reminder on some dumb stuff. That's how like I'm not paying attention.
What is 10 to the 5th power?
50.
I'm gonna get my,
I know.
100,000.
100,000. What is 10 to the 4th?
10,000.
10,000. What is 10 to the 3rd?
The power, take them back to Hans.
10,000.
Yes.
Do you have to put the
There's
commas?
a lot of zeros.
Now, you can just plug this into your calculator, but because I don't have one, I'm doing step by step. But the day of your test, you have a friendly calculator, right? So this becomes 200,000 minus 30,000 plus 1,000 minus 200 plus 10 minus 8. Now, 200,000 minus 30,000 becomes what? 170,000, right? 1,000 minus 200
800.
plus 800 and 10 minus 8, 2. So when I put those together, my answer is 100.
170,800.
This here is your remainder. That's your remainder. That is all they want for you to do in that question. Find your remainder. This is you using the remainder theorem. But this could also be done using synthetic.
On the test, when you just use the calculator and plug that thing in. Good, so what?
Will you give us numbers that day?
Oh, I don't know, it just depends, but you have a calculator, you'll be okay. It's just multiplying, that's all it is.
Calculator, give me 2 seconds.
I would love if you do it with a calculator, which you're allowed to, I at least want to see this sentence where you show me that this is what you're inputting into the calculator. This algebraic sentence.
Alright, discussion.
So, for synthetic division, what do you think is my number that goes outside?
10.
The 10. Who are my leading coefficient? 2,
-3,
-3, 1, and -8. So we bring this guy down, and this is a, what happens to the,
It's a 20.
oh, sorry, that is supposed to be a 10, thank you. I put a 1 and that should be a 10.
Wait,
Oh, 10 minus 8.
Wait, what?
From the top.
Yeah, you wanna pop it in too,
Minus eight.
I'll just about to call.
Oh.
Nah,
No, wait,
I won't.
no, it is a one.
Just
It's
say,
the original.
Just kidding. We're going off the original. It is a one,
Oh,
and it
okay,
is a
so we
minus
go
eight.
off there.
because it was only 10.
Yes.
Man,
Okay.
I
So,
got good.
10 times
Sale.
2 is
20.
20. This becomes 17. 17 times 10, 170. This becomes 171. All you do when you multiply times 10 is add a what?
0.
0. So don't make it harder. Some of you y'all drown in this much water, guys. Don't do it. Swim. So 10 times this is 1710. We subtract 2, 1708. When I multiply times 10,
$17.00.
and we add,
Damn, that's like the church's money with this.
And then 17.
and we subtract the 8.
1, 7, 0.
This here
Hey, this is.
and that, it's the same thing. So you have a choice whether you want to use the remainder theorem or you want to get your remainder using synthetic division, whichever one you feel more comfortable with. Bless you.
Thank you.
Are we okay?
I like it. It's better.
Yeah, I'm looking at that.
Okay, whichever way you want to. Example number 6. Determine if 5 is a 0 for, so determine if 5 is a 0 for g of x equals x to the 4th minus 26x squared plus 25. Now, how can you determine if what they give you is 0?
Make sure there's no remainder.
Make sure that there's no remainder. And you have 2 ways to do it, long division or synthetic. I'm gonna use synthetic. Now, what is the number that goes outside in the little box?
The 5.
The 5, because that's the number they want you to
They already gave us a 0.
check. Yeah, they already gave you, but you're checking, so it's like a yes or no kind of question.
0.
Now, when I do synthetic division, what are the numbers I'm gonna put here?
1,
0, negative 26, 0, plus 5.
Alrighty. We bring down the first dude,
Everybody, why is there one?
Okay.
because it's x to the 4th.
and there's a 1 there, even though we don't see it. Okay, so we have a 1, that's a 5, that's a 5, 25, negative 1, negative 5, negative 5, negative 25. And what is your remainder? 0.
Yeah.
So, yes, 5 is a 0. Beautiful. If they ask you, what is your quotient? Just because this is your remainder, this is your c, this is your x, this is your x squared, and this is your x to the 3rd.
And we always go back.
Always backwards. X to the 3rd plus 5x squared minus 5. That is your answer.
So the number underneath the one that's public quote.
Mm-hmm.
Okay, I'm stumbling on those words.
It's okay. All right, the last example from this section. Am I okay to turn?
Wait,
Yes, sir.
What?
An R. That's your remainder, your constant, your x squared, and your x to the 3rd. If f of x equals x cubed minus 3x squared minus 6x plus 8. find a zero and factor. So I think the last problem is like this on your assignment. You have to do trial and error. Because at this point, they haven't shown you how to figure out what the zeros are. The only thing I can tell you is you look at your constant, and it's going to be numbers that are your constant or smaller. So I am going to start off by trying a -1. I am going to use synthetic division because that's the one that requires less work. And if I'm just going to be playing with numbers, figuring out which one it is, I don't want to be doing the long division way. My numbers for synthetic division is 1,
3,
-3, -6, and a +8. So go ahead and do synthetic division. I'm going to do it quietly. You just pick a number. I'm just picking a number right now. But I know it could be 1, 2, 3, 4, 5, 6, 7, or 8, either positive or negatives. Because my last number is 8. So, it can't be anything bigger than 8 because your constant is 8. -4, +4, -2, +2, and then 10. Is this a 0?
No.
No.
Can you just set the f of x to 0?
I just got a synthetic way.
If you set this to 0?
Yeah.
And how would you solve? You can't factor out x because the 8 doesn't have an x. You have to, but not right now. So, if 1 doesn't work, let's try a +1. So we're going to try a +1. We're going to redo synthetic. 1, -3, -6, and 8. Bring down the 1.
You only do the opposite, -1 or 1.
I would do -1, +1. -2, +2.
So if it's -2 to do it, if it's -2 didn't get you, you do +2.
Yeah.
Supposed to get the
Oh,
lowest
no,
of
it's a -11.
Yes. Oh, you thought this was an 11.
Yeah.
Sorry,
Yeah,
it's
I
the
did that
little,
first.
it's the little box. It's a -1.
I was like, why did you box it in?
This is a +1.
You gotta be told the 1 or low 1.
All right. 1 times 1 is 1. -2, -2, -8, -8, and 0. Is this a 0?
Yes.
So my P of X, my whatever, right? Now, what is this as a factor?
X all -1.
Very good, thank you. What?
How did he get that?
It's an X minus 1, because
You
remember,
said it's a 0 and
Yes.
it's +4.
so this is a 0, but I need to write it down as a factor, alright? So this X minus 1 came because that's a +1. Now, this becomes X squared minus 2X minus 8. Just remember, remainder, constant, X squared. So if I were to multiply both of those, distribute, who do I get? This answer, right?
And that's
Now, can you factor this any further?
Yes.
What two numbers multiply to a -8 to add up to a -2?
4 and 2.
4 and 2, who's negative?
The -2.
-4.
The 4, right? So this actually becomes X plus 2 and X minus 4. I am not sure if they're gonna make you factor all the way, or is this gonna be okay with them, but in case they do, you take it to the next level.
Are you testing?
So the answer won't be,
Yeah, that's a sloppy way, right?
but the answer will be like X equals +1, X equals -2, X equals +4.
No, they would want the factors, not the actual zeros. They would want the factors, not the actual zeros. So that is 4.5. On Monday, when I said it was hard, it's just a little bit more intense. Not that it's difficult and you're not gonna be able, you should be able to do this. It's just multiplying, factoring, Are you ready for 4.5?
Wait, I thought you just said that was 4.5.
No, that was 4.3.
You just said.
Okay, well, I said the wrong thing, but we labeled the beginning what? Okay, so it was 4.3.
I missed that.
So, 4.5, rational functions.
Is this harder?
I don't think it is. Rational functions, I love. If you still don't know how to factor, it's gonna come and kick you in the angle side right now.
What?
So, a rational function is a fraction of two polynomials. So, having one is not enough, you're gonna have two, one on top, one in the bottom. The first thing you need to figure out is to find the domain. Find the domain. And we've done this before. And you find the domain by setting your denominator equal to 0. We've done it, we did it when we were covering stuff in the first test. Now, the first problem you have here is going to be 1 over x minus 3. So we're going to start easy, right? And then we're going to go into something a little bit more intense, but not bad. Your denominator is who?
X minus 3.
So x minus 3, we set it equal to 0, and I get x is what?
Positive 3.
Or positive 3. But your domain, remember when we have to do not equal to 3? Because what would happen if this is a 3?
It'll be 0.
And 1 over 0 is
Not a real number.
not a real number, it's undefined, you can't do it. Or, remember when we had to write this in interval notation? Negative infinity to 3, union 3 to infinity? You remember that? So we've done this part before, the domain part. It's just now, you're gonna use it to find the vertical asymptotes.
What?
Yeah,
What is, never forget.
we'll find out.
It's gonna last.
F of x equals 1 over x. Who's your denominator?
The x.
The x. So we set that equal to 0, and it's already solved. So when I do this, all x such that, what?
Cannot equal to 0.
X cannot equal to 0. And then my interval notation is
Negative infinity.
0 and 0 to infinity.
It's always the denominator.
But then you get problems like this. X minus 3 over x squared plus x minus 2. What can we do?
You have to factor it in.
We have to factor your denominator. So your denominator right now is x squared plus x minus 2. What two numbers multiply to a negative 2 but add up to a 1?
2.
But who's positive, who's negative?
The 2 is negative.
The 2 is positive, and the 1 is negative. So negative 2 and a 1 has to be a positive 1. So my 0 here is,
Negative 2, positive 1.
so when I do my domain, x such that x is not equal to a negative 2, and x is not equal to a 1. And when you do your interval notation,
Infinity.
negative infinity to
Negative 2.
negative 2,
Negative 2.
1, 2. So, if you recall, when we were doing this the first time, it was if you only have one number in here, you end up with 2 parts. But because we have 2, you end up with 3 little parts right there, right? Do this last one. F of x equals 2x plus and 2x minus 6. So try to do that one right there. So your denominator, what can you factor out?
It's just software.
Okay, so yeah, we solve for x, sorry. So 2x is 6, we divide by 2, then x is a 3. So x is not equal to 3, and negative infinity to 3, union 3 to infinity. So that is you finding the domain.
So we just care about the denominator.
For domain, yes.
Yeah.
Like if the question is just saying, who's your domain, that's all you look for. Only work with your denominator. All right. Are you ready for the next part?
Hold on.
Because there's like 4 different sections, 4 different topics within this one.
And this is only for the next one, so.
So it's 2 sections, 6 columns in each one, 12 problems total. We'll see how things, we'll see how things are on Monday with the review. Vertical isotope. Now, this also comes from set your denominator equal to 0 and solve. F of x, so your function consists of p of x over q of x, which means a polynomial over a polynomial. When you do this, we need to make sure that p of x and q of x do not have a factor in common.
Hold on one second.
I'm just writing, I'm not explaining. If they do, it's a good. So, to find your vertical isotope, we're gonna do the same thing we're doing. So, you know how you were solving for x, but we were using it for the domain? Those are your vertical isotopes. Now, does somebody have a TI 83 and 84 that's not the lead? That one, I can't show it here. Okay, bring me that one, Trevor, please. But the screen doesn't let it show, Georgia.
Oh boy, on that pink breast cancer.
More like 3.
You still got that?
What's that?
I like it, can I keep it?
I gotta give that one.
See that, he's gonna let you do.
All right, so when we do this, we only care about the denominator, but we also care about the numerator, because if something is in common in the numerator and denominator, it is not a vertical isotope, it is a hole in the graph. So what does this here mean? So for example number 2, find the VA, and VA is a vertical isotope. We're going to look at the first equation. F of x equals 2x minus 11 over x squared plus 2x minus 8. So you ask yourself, can I factor my numerator? Is there anything that you can factor out? No.
It's standard.
If it's already 2x minus 11, nothing's in common, so it stays. But your denominator, I have x squared plus 2x minus 8. What 2 numbers multiply to a negative 8 to add up to a positive 2? 4 and 2. Who's positive, who's negative?
Negative
four.
No, it's negative two.
The positive 4 and the negative 2. Because I needed to add up to a positive 2.
Okay, hold on one second, sorry.
So what is the 0 to this?
That's the one negative in there.
And what is the 0 to this? So my vertical isotope, because there is nothing to do in the numerator, my vertical isotopes are x equals negative 4 and x equals 2. You are done. Now, what does this vertical isotope do to your graph? Let me just show you. I'm inputting it. I'm changing it over here. Okay. So this is, you have to, when you plug it in, you have to put it over parentheses. I mean, around parentheses, your numerator over your denominator. And if I graph this graph at negative 4, there's an imaginary line right there. And at a positive 2, there's an imaginary line. Your graph does not cross or touch that. Your graph comes here and then it jumps and it starts up here and then it jumps and it starts down here. Rational graphs always look like this.
So they're just barriers.
Now, it is, yes. I used to explain them to my high school students as they're electric fences that you get close to, but you don't cross it and you don't touch it. Because if you do, you're going to kill some of those brain cells you have. And you don't necessarily die, but you know,
Don't
no crying. Now, please notice the way it shows up on your table. Negative 4, it says error.
There's no negative.
2, it says error.
Those are where it jumps.
Because those are where these lines are at. There's no part of the actual graph is there. Okay? So using the table helps you also verify what your answers are. So let's try one more. B, h of x equals x squared minus 4x over x cubed minus x. So when I look at that, can I factor something from your numerator? And x, right? This factors and I get x minus 4. Because we factor out an x in here, we have x, we have to factor out an x there, we have a 4. How about the bottom?
Next.
An x, and I end up with x squared minus 1.
1, because that sounds wrong.
Can I factor that any further?
Yes.
It is x squared minus 1, it's a difference of perfect squares. Can you take the square root of 1?
Yes.
Yes. What is it?
X plus 1, X minus 1.
Yes, ma'am. This becomes x plus 1, x minus 1. This is still x, and this is an x minus 4. It's like if I had x squared minus 16, it becomes x plus 4, x minus 4. We talked about the difference of squares earlier. Maybe briefly, but we did. Now, remember, if p and q don't have a factor, you're trying to make sure they don't have a factor. But if they do, it's a what? Whole. Do they have a factor in common?
Does the x count?
The x counts, because that right there is a whole. So the only thing that you're going to have for my vertical isotopes are going to be x equals 1 and x equals a negative 1. These are your only vertical isotopes from here and there. If they ask you, hey, there's a hole, well, what's your hole? X equals to 0. Because when you set each of these equal to 0, that just stays as x is equal to 0. Now, let me just show this quick.
Vertical acetone
Mm-hmm.
is the 1 and the negative 1.
It's these two.
We don't worry about the 4.
No, because remember, it only comes from your denominator, but the reason you have to do this is because if I didn't do this, and this would have x is equal to 0 also. But it's not a vertical isotope, it's a whole. And I'll show you what. So at -1, it splits, at 1, it splits. Now, if I go to the table is gonna show the word error, because there's a hole. So if you actually graph this, this is a 1, there is an asymptote, At 0, there is a hole, which means an open circle. So this graph goes there, and it goes like that. It is hard to see on the actual graph, but that is exactly what happens. There's a hole there, you can't see it, it's hard to see.
They call it a hole because
It's an open circle, it's a hole in the graph. And this tells you it's a hole because you have the same factor in the numerator and denominator. Okay, the last one to try from this section. C of x minus 2, x cubed minus 5x. Can you factor anything on top? No. Can we factor anything on the bottom?
Yes.
An x, and we end up with x squared minus 5. Can we take that any further?
Yes.
Factoring wise?
No, it's not.
So now, what do we have to do? Set them equal to 0. So I have x is equal to 0, but also x squared minus 5 is equal to 0. This one's already done, correct?
that comes from the top.
No, from here.
Oh, okay.
And that's from there. Plus 5 is correct, thank you. Next thing, we have to square root. So I get x equals a plus or minus square root of 5. So my vertical isotopes, x is equal to 0, x equals the square root of 5, and x equals a negative square root of 5. Those are your vertical isotopes there. 1, 2, and 3. Next thing, the third topic, remember to do was 4. Oh, no, not yet. Shutting down is not an option right now. It is. And then you have to make sure you don't go and put it away until next Tuesday. You need to take it home and start looking over it.
Yeah.
Horizontal asymptote.
Now you said it right. You've been saying isotopes and
Asymptotes.
making me want to like.
Look at the degree. So in order to find the horizontal one, we only care about the degree. The degree is the largest exponent of whatever you're having, or whatever your polynomial is. So if the degree of numerator is less than the degree of the denominator, then your horizontal one is y equals to 0. It's 3 rules for this, and you have to know the 3 rules.
Hold on 1 second.
I'm just writing the 3 rules. If the degree of n, meaning your numerator, is equal to the degree of d, which is your denominator, then your horizontal asymptote is going to be at y equals LC over LC,
Oh God.
and your LC stands for leading coefficient.
LC over LC?
Yes, LC over LC, leading coefficient over leading coefficient. It's just because remember it's a fraction, so whatever the leading coefficient is on top over the leading coefficient at the bottom. And right now, we're going to do an example where you're actually going to see it in play.
So that's the second rule.
That's the second one.
Okay.
The last rule. If your degree of your numerator is greater than the degree of the denominator, then there is no horizontal asymptote. There is an oblique. So those are the three rules, and we're gonna do one of each so you can see exactly what it is. So, for example number 3, I believe, find oblique, O-B-L-I-Q-U-E, oblique. It's okay. Find you just say it in such a nicer way than some other people.
Is it really gonna like make an oblique, like on the graph?
Oblique, what does the word oblique mean to
It
you?
needs to like, shit.
It's a slant.
Right. In
It's like you
engineering,
do-
that's how we do oblique.
So they use the word oblique or slant, it means the same thing.
Right.
So g of x, 2x squared plus 1 over x squared plus 3. You only care about your what? Your degree. You only care about your exponent. You only care about your degree. What is my degree up here?
2.
What is your degree up here? Are your degrees numerator less, equal, or greater than?
Equal.
My degrees are equal, so it says y equals your LC, who's your leading coefficient here? 2, over the leading coefficient of 1, which means it is just a 2. There is a horizontal on that one. Okay?
Hold on, can you say it all there?
That's the answer, yes. We look at the degrees, because it's a 2 and a 2. The degrees are equal. Y equals LC over LC, meaning leading coefficient over leading coefficient. My leading coefficient here is 2. My leading coefficient here is 1, so it's 2 over 1, which is 2.
It kind of reminds me of what was that one where like,
We have to plug in rules.
yeah, you know that like 3 volts they have? I'll show you.
Like if it's greater or less
Piece
than
wise,
100.
okay.
Yeah, that's it. That's what it reminds me of. Right.
Yes, it's like,
You know that thing?
I know, what
Thing
thing?
Right. Great. Thanks.
I know.
Thanks, guys. Thanks for.
Alrighty, this one, what is your degree of your numerator right now?
2. 1.
One.
Numerator 0.
Oh, yeah.
0.
0.
Remember, your degrees belong to your variables. Is there a variable on top?
No.
No. So my degree on top is 0, my degree on the bottom is?
2.
So is the numerator less or greater?
It's less.
Numerator is less than the denominator, so it is just y is equal to 0. Boom, there's your answer.
But how do you know what it wants you to look at? The top?
Oh, you have to look at both and compare them. Yeah, I need the degree of the numerator and the degree of the denominator. I need both, and then you either decide, is the numerator less, equal, or greater than? You need your degree of both top and bottom. So, the last one for this section. F of x equals 2x squared minus 3x minus 1 over x minus 2. So, point out your degrees on your paper. Degree for the numerator, degree for the denominator.
2 and 0.
2 and 1. You only look at your greatest degree.
Which is 2.
2 and 1. So my numerator is larger. So there is no horizontal isotope. I need to look for my slant or oblique asymptote, which takes us to the fourth thing we need to learn today, and last. So as long as you have those rules and you look for those degrees and you compare them, So remember, degrees only belong to the variables. It is
Degrees.
the exponent of the variable. All right, example number 4.
I know what that is.
Find the slants/oblique. They use both. I have no idea which one they're gonna use in your questions, but they mean the same thing. And you only find the slant/oblique when you are, and, yeah, when there's no horizontal asymptote. So I'm gonna rewrite this problem, because that's the one that has it, so we can have it here. 2x squared minus 4x minus 1 over x minus 2. When you find the oblique or slant asymptote, you're basically, all you have to do is synthetic division. And do you know how to do synthetic division? Yes. So what is my number that goes outside?
Two.
The 2, and we're getting that from the denominator, right? So that's your divisor. That is your factor, that is your divisor. Now, what goes here? This number comes down, and this is 2. So multiply,
4,
4, 1, 3, and 2. Nope, just kidding. This is a 2.
I'm the same.
I'm so sorry, I apologize. Now, this is your who? Remainder, constant, and x. Real quick.
2 on the outside of your little thingy. It comes from that.
Yeah, because it's your divisor, it's what you're dividing by.
I think I'm gonna do the
Your
red.
divisor, so
That's what the red and black pen shows you, like,
you have to set it
How you're
equal to 0.
you know? So if your brain can comprehend.
You have to set it equal to 0,
Right.
so you can put it there.
So the 2x plus the 1,
That's honestly what it is when you sleep.
oblique.
Our brain's like,
Yeah.
not.
Now, what is your oblique asymptote here? You don't care about the remainder, you care about everything that's gonna be this way. So y equals 2x, plus 1.
That's it.
This is your oblique,
Yeah, 'cause that's the
Yes.
constant, plus the
So what do you
constant.
do for a
So that's
negative?
plus the-
We don't worry about that.
You don't worry about
not for this one. So, just FYI, if you actually had to graph this line starts at a 1, you have a slope of 2, so I don't know if you remember how to graph lines, you start off at your y-intercept, you go up to rise over run. There is an asymptote here, this is your slant asymptote. Now, who's your vertical asymptote? If so it's at 2, right?
So it can't be any of those like that.
So my graph is either gonna be found here, 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 or here. And you don't know until you graph it. But this sets your limits. That's what the asymptote does. It sets your limits. And I'm just gonna graph this so you can see it, and that is the last thing. 2x squared minus 3x minus 1 divided by x minus 2.
I'm sorry.
She got 2 into a lesson, she forgot.
Yes, thank you.
Bye. She has to go pick up her. So we look at the graph, and where is it? It's in here, and it's in here.
Just like you said it would be.
Well, I said, I wasn't sure what 2 sections, but that's exactly what.
Are you gonna ask us to graph this on our homework?
I don't think they have to make you do the graphing part, but they do make you do everything else. All right, guys, that's it. If you have homework, you can bring it. Yeah, it's only 3.2.